It's glad to see you all back. Here we have started lecture series on ring theory. Not only on ring theory subject, we have started lecture series on complex analysis, linear algebra, group theory, and other all subject which is useful to our CSIR, NET, SET, and GATE exam. So if you wanted to check this video, you can check it into my playlist. So in my today's video, I will go through one of the topic from integral domain, which is from ring theory. Okay, it is very much important topic for our today's lecture. Okay, so in my first session, I will explain to you all the definition of integral domain, and then further we move for some of the example which depend on the integral domain. Okay, we'll see the definition example which hold the definition of integral domain and which violate the definition of integral domain too. Okay, now let's get started our today's lecture. Here it is the definition of integral domain. Okay, so always remember, so if you are taking ring, then always it need to satisfy commutative ring. In a zero divisor, in my previous lecture I explained zero divisor, so that time we also need a commutative ring. So always remember that property need to satisfy. Okay, so here it is the definition of an integral domain. So integral domain is the exact opposite side of a zero divisor. That means in a zero divisor we taken a non-zero, b non-zero, but their product is zero. But in integral domain we have to go for exact opposite. If a dot b is zero, that means one of the a0 or b0. Okay, one of the condition a0 or b0 need to be there. Okay, so this is the definition of integral domain only. Okay, now let's read the definition. A commutative ring with a unity r under the addition dot is said to be an integral domain if a dot b, okay, it is need to be commutative ring, it need to hold unity. Okay, so unit, what it is the unity and unity element, I already explained in my previous lecture. Check it into my playlist. Okay, so when we said it is integral domain, we have two element a and b, their product is zero. When a is 0 or b 0, one of the a or b need to be 0, and a and b both are coming from a ring. Okay, or we can write one more way. Okay, that definition, a dot b which is non-zero, then a non-zero and b non-zero. Okay, so if their product is non-zero, then we write their a non-zero and b non-zero too. So here it is the definition second, a non-zero from ring, b non-zero from ring, then we write their product it is also non-zero. Now see, this is the opposite side, like one side it is from the integral domain and another side it is from zero divisor. Both are the exact opposite to each other. Okay, so we have to find integral domain. Then obviously if integral domain is there, then we can say zero divisor is not there. If integral domain is there, then the integral domain is not there, then zero divisor is there. Okay, so these are the quite opposite to each other, so it is easier to figure it out whether integral domain or zero divisor. Okay, now let's find out some of the example depending on integral domain. Okay, so here my first example is here r which is equal to z, which is integral domain or not. Okay, so we know that z is infinite ring here, r which is equal to z is an integral domain. So now let's consider two element, a belongs to z, b belongs to z, and so that a dot b is a 0. Okay, so under z we know that if I consider a0 or b0, okay, so we have to check z is integral domain or not. That means we want the element there a0 or one of the element is 0 and z contains 0. If I consider z a as a 0 from z or b as a 0 from z, surely if we multiply 0 to any element we will get the 0. Okay, so the first definition a dot b is equal to 0, that a0 or b0 it's satisfied here. Okay, so we say that z is integral domain. Okay, similarly you may try for your homework. Q, R, C, Z, I is integral domain. Okay, why it is integral domain? 0 belongs to Q, 0 belongs to R, 0 belongs to C, 0 plus 0i belongs to Gaussian integer I. Okay, that's why it is an integral domain. Okay, so this one is the first example that we prove here. Z, Q, R, C and Gaussian integer all are the integral domain. Here in my second example, I consider here z cross q. Okay, is integral domain or not? Okay, if 0 belongs to z, 0 belongs to q, surely we'll say that it is an integral domain. Okay, now let's find out is it integral domain or not. Okay, so z cross q, if I consider non-zero a and non-zero b, okay, so you may apply second definition to z cross q. I consider here which is a z cross q is a commutative ring with unity. Okay, so I consider here first element 1 0, second element 0 1 from our z and q. Okay, 1 0 from here, 0 1 from here, but we can see a non-zero, b non-zero, but their product is a 0. Okay, corresponding multiplication 1 into 0 0, 0 into 1 is 0. Okay, so here we can see a non-zero, b non-zero, but their product is 0. So this is the definition of a zero divisor. That means it is not integral domain. So if zero divisor exists, that means it do not possess its integral domain property. If integral domain property hold, then there does not exist zero divisor. Okay, so here we can say that this is not integral domain, this one is the zero divisor. Okay, so a non-zero belongs to our group Z cross Q, and 0 1 also non-zero belongs to Z cross Q, but their product is 0. So this is the definition of a zero divisor, and obviously Z cross Q is not a integral domain. Okay, similarly you try for R cross R is integral domain or not. Okay, so it is a zero divisor, it is having zero divisor. Okay, that's why it is not integral domain. So similarly I have some of the example for you all, like Z cross Z, Q cross Q, R cross C, C cross C, Gaussian integer mod I cross Gaussian integer I, all are not integral domain. Okay, so try this example for your homework. These are the quite easy examples. Okay, that we how to just find out how to find out only the one counter example where our example is integral domain or having or zero divisor. So here in my next example I consider here in general result. Okay, if Zn is an integral domain if and only if n need to be a prime. Okay, so when n is a prime, it is not a zero divisor. Okay, it do not have zero divisor. But Zn, when n is a prime, then it is an integral domain. That means Z prime always integral domain, and n it is not equal to prime, then Zn is not integral domain, but it is a having zero divisor. Okay, now here it is the examples Z1, Z4, Z6, Z8. These all are not non-prime element, so it is not integral domain, but it is zero divisor. And Z2, Z3, Z5, Z7 all are prime number. It is an integral domain but not zero divisor. Okay, now let's find out one more example whether it is having integral domain or not. Okay, so Gaussian integer modulo ni is an integral domain or not. Okay, but we cannot say it is integral domain or not. Okay, so it is need not, we cannot say about it because it possesses both of the property. If I consider case first, okay, n which is equal to not prime. Okay, if n is a non-prime, we already learn already. Okay, if n is not prime, then Zn I is not integral domain. Okay, so that means Z prime I, it is not integral domain. Or for your understanding, you may take Z7I as a counter, Z7I, Z8I as a counter example, and figure it out whether it is a prime or not. Okay, integral domain or not. So Zni is a not integral domain when n is not equal to prime. If I consider n is equal to 1, so case second, n is equal to 1. Okay, if I consider n is equal to 1, so it gives Z1I, and Z1I having only one element, 0 plus 0I, that means only 0, and it does not belongs to unity. Okay, unity, we do not have unity here in our set, so which is only one, it is not there, that's why unity element not there. So the second property it break here. Okay, so second property do not hold, that's why it's get violated by second property. So by first second we say that it is not integral domain. Or case third, if n is equal to prime, then Z prime I need not integral domain. For this we may consider any counter example like a Z5I and check it whether it is integral domain or not. Okay, so this is only for our today's lecture. I hope you all have understood the definition of integral domain along with the examples, and I explained here some of the general condition with the properties. Okay, so this is only for our today's lecture. Thank you everyone. Thank you for my today's lecture.